Welcome to today's webcast, Improve Developer Productivity with Visual Studio and TFS 2013. My name is Colin Dembowski. I'm an ALM MVP based in East London, South Africa, and I work for a company called Imaginet. I'll have a bit more on Imaginet service offerings at the end of the webcast. My Twitter handle is Colin Dembowski, and I blog regularly to colinsalmcorner.com. Before we start today's webcast, I'd like to tell you a little bit about Imaginet. We have over 650 successful ALM customers and over 1,800 successful ALM engagements. We're a Microsoft Gold certified partner with the ALM competency, and in 2011 we were Microsoft's ALM Partner of the Year. We have only the highest level of expertise with Microsoft ALM technologies and a close working relationship with Microsoft. On staff, we have multiple Microsoft Regional Directors, TFS Rangers, Virtual Technical Specialists, and many Microsoft MVPs. In today's webcast, I want to look at productivity features specifically designed for developers. I want to review 4 features that were introduced in Visual Studio 2012: My Work, Code Reviews, Unit Test Adapters, and Fakes. Then we'll move into 2013 features such as Team Rooms, Code Maps and Code Lens, Memory Diagnostics, Git Source Control, Coded UI testing for Windows Store apps, and lightweight code comments. I've opened up Visual Studio 2013. Although I'm using Visual Studio 2013 Preview, the My Work feature was introduced in Visual Studio and Team Foundation Server 2012. I'm going to open up the Team Explorer, and from the home page I can click on the My Work feature. This is available in Visual Studio Premium or Visual Studio Ultimate. There's a couple of sections to the My Work pane. I want to focus in on the Available Work Items section. Here I have a task that's been assigned to me. I'm logged in as Adam. I'm going to grab this task and move it up to the In Progress Work section. That'll transition the task from To Do to In Progress for me, so I don't have to do it manually on the task. Now I'm going to make some changes to the code. If I look at the My Work pane, I can see the task I'm busy with, task 249, as well as what the pending changes are. I have 1 add, 1 delete, and 3 edits. If I click View Changes, it'll open up the Pending Changes view, and I'll be able to see what changes I've made. While we're on the Pending Changes view, an optimization in 2013 is to change the view from the tree view to the list view. You can also see I can pop out this Pending Changes pane if I so choose. Let's switch it back to the tree view again. We'll press the back button to go back to the My Work pane. Unfortunately, for us developers, we're often interrupted with what we're working on. Now I may not be ready to check these changes in, but I may have to switch context to fix a bug or do some other work. Instead of losing my changes and losing the place that I am in Visual Studio, I can use the suspend to suspend what I'm busy with. I'm going to open up a file and set a breakpoint. Maybe I'll open up the Architecture Explorer, and let's open up the Test Explorer window as well. So we've been working, we've got some changes, and we've got Visual Studio set up just the way we want it for the work we're busy with. Unfortunately, we're interrupted for some reason and we have to change contexts. I'm going to click the Suspend button. It's going to take the title for the suspension from the title of the work item we're busy with, and I'll hit the Suspend button. This is going to shelve all of my changes, as well as the state of Visual Studio, up in a shelve set on Team Foundation Server. So my changes are there. The Suspend button then goes and undoes all of the pending changes in my workspace so that I'm back to what's exactly in source control. Let's close the Test Explorer window and the Architecture Explorer window. And let's imagine that we've finished now working on whatever it is that caused the interruption. Now I'm ready to resume and go back to where I was working. I'll click back on the Team Explorer, and here under Suspended Work there's a Resume link. You'll also see there's a Merge Within Progress. This Merge Within Progress would light up if I've actually made any changes If I've done so, merge within progress will cause a merge between the shell set and the changes I have. In this case I don't have any changes, so I'll just hit the resume link, and that's going to rehydrate Visual Studio. You can see it's opened up the Test Explorer window as well as the Architecture Explorer window, restored the file that I was busy working with, as well as all the pending changes. I want to now show you code reviews. Again, even though I'm using Visual Studio and TFS 2013, the code review workflow was introduced in Visual Studio and TFS 2012. Again, in the My Work pane, I can see a request review link. I'm going to hit request review, and we'll enter in the name of our reviewer. Let's ask Brian Keller to do the review. We can add multiple reviewers if we so choose. I'll submit this request. That's created an outgoing code review in the My Work pane for Adam. Let me launch Visual Studio as Brian. Brian's going to open up his Visual Studio and click on My Work, where he'll see a list of his available work items, as well as the incoming code review that Adam Bars requested. I'm going to double click on it to open it up. Here Brian can accept or decline this review. Accepting it will let anyone on the team know that Brian's busy working on this code review request. Brian can then double click the related work item to get some context to see what changes Adam was busy with. He can click on any of the files to see what changes have been made. This view does a diff. On the left is what's in source control currently, and on the right are the changes that Adam is making. Brian is then able to highlight any piece of code, right-click and select Add Comment in order to comment a piece of code. Brian can then send those comments by clicking the Send Comments button. Let's switch back to Adam's Visual Studio. If I refresh this, I can see that this code review is in progress because the text has been bolded. Double clicking it will open it up in My Work, and I can see that Brian's accepted it. If I scroll down a little bit further, I can see Brian's comments. If I click on that, it's going to show me the code that Brian has highlighted. I'm able to reply to this comment. Again, I can send the comments back by hitting Send Comments. In this way, the reviewer and the reviewee can have a conversation that's recorded on this work item inside of TFS. Let's switch back to Brian's Visual Studio and complete this review. Brian would then be able to check mark each of the files he's completed until he's completed the entire review. He can add an overall comment if he so chooses, and finally he can finish this with one of three final statuses: looks good, with comments, or needs work. We'll end this with a looks good. When Adam refreshes, he can see that Brian Keller has finished this review with a looks good status. Let's now go back to My Work and click Check-in. You can see here that the check-in is associated with two work items. Task 249 is the task that Adam was busy with. This is the task that he dragged from available work items to in-progress work items in the My Work pane. This check-in is now also associated with the code review for this particular change set, so that if anyone audits this, we can see who performed the code review and exactly what the conversation was as well. Unit testing is something that all developers should be doing. I'm going to open up the Test Explorer window by going to Test, Windows, Test Explorer. This is going to show me a list of unit tests in my project. In Visual Studio 2012, the test adapter was improved to be able to show tests from multiple frameworks. It can show MS tests, X unit tests, N unit tests, and any other framework for which there's a test adapter. Test adapters can be installed using the Visual Studio Gallery. Here we see a list of tests. If I open up Service Tickets Controller Tests, you can see that it's using the N unit framework, while the Home Controller tests are using XUnit. Of course, I have other tests that use the MS Test framework as well. Since I have the adapters installed, I see all the lists of tests, irrespective of which testing framework is being used. Here I have the tests grouped by class. I can use this grouping drop down here to change the grouping to various other properties. We can also create playlists. Let's select the first 10 tests over here. I'll right click, select add to playlist and create a new playlist called tests I really care about. Now on the playlist setting, I can select that list of tests and it'll filter out the tests for just the tests in that playlist. We can turn on continuous testing by selecting this Run Tests After Build button. That'll execute the tests every time I build the solution. I'm going to hit Run All to run all the tests. Here you can see you get the red-green indicator showing which tests have passed and which have failed. We can also analyze code coverage by selecting Run, Analyze Code Coverage for all tests. That'll run the unit tests and calculate code coverage as well. Once that's completed, we can open up the code coverage results and inspect the coverage. If we open up a file and select Code Coverage Highlighting, Visual Studio will show us which lines of code have and have not been covered by our tests. The Microsoft Fakes framework was introduced in Visual Studio 2012 and it continues in Visual Studio 2013. Here I have a test method that tests the index method of my weather controller. This index method has a dependency on a repository which calls down to a database. In order to unit test this method, we'd ideally like to remove the dependency on the database. To do this, we can use any kind of mocking framework like RhinoMock or TypeMock or NMock. Fortunately for us, the repository has an interface defined, and so we could create our own implementation of that as well. I'm going to show you how we can use the Fakes framework to save us a little bit of work. If I open up the references for the tests, I'll see the reference to my data access layer. If I right click this, I can select Add Fakes Assembly. That'll add a Fakes assembly for the data access layer for me. Now instead of creating a concrete weather repository class, which is a class that calls down to the database, we can create a stub for the interface. Let's create a new method called getFakeRepo. We'll let Visual Studio generate a stub for that. Now we're going to return a new stub iWeather repository. I'll resolve this reference. It's sitting in the data access layer.data.fakes namespace. If I look at what methods this stub has, it's got an all and all for week date time method. These are the two methods on that interface. We're going to provide a lambda for the all for week date time method. This method takes in a date, and we want it to return some fake data for us. I'm going to paste in the fake data. We're now able to put whatever code needs to execute when the all for week date time method is called. In this case, I'm returning a set of fake data. Let's now run this test. Let's run that test again and analyze code coverage. If we go to the weather controller class and turn on the code coverage highlighting, we can see that we've covered most of the method, except for this if statement here. If we look closely, we'll see that this if statement has a dependency on date time today. This is really difficult to test, since there's no interface that we can override or mock out. This is where the true power of fakes comes in. We're able to create a shim which will allow us to intercept calls to any class, our own or even framework classes. Let's go back to our test method, and again I'll right click a reference. This time it's going to be the system reference, and I'll select add fakes assembly. This is going to create the fakes assembly for the system types for me. Now you see I have a system 400 fakes assembly. In order to use shims, we have to create a context within which the shims will operate. We'll do this using a using statement. And we'll call the shims context.create method. That'll create a shims context for us. We'll then use the shim for the datetime class. We do so by again resolving the reference from system fakes shim datetime, and here I can see all the methods on the datetime class that I can intercept. We're looking for the today getter. And here we'll give it a lambda to say whenever someone calls the today getter, return the following code. We'll give it a new date time, and we'll make sure it's a day that's during the week. September the 25th is a Wednesday. So now we know whenever datetime.today is called, it'll return this date. That's a date that's during the week, and so the rest of our test should work. We can then copy and paste this test to create a test that'll test for a weekend day. Let's give it the 28th. If that's the case, our code behaves slightly differently. Recompiling will surface the new test in the Test Explorer window for us. We can now run both tests, analyzing code coverage at the same time. Let's go back to the weather controller and turn on the code coverage highlighting. Here we can see that using fakes we've been able to remove the dependency on the database, as well as test hard to test code, like code that has dependencies on date times. TFS 2013 further enhances team collaboration by using what are called team rooms. This is like a log of events that happen inside of TFS, mixed in with the ability to chat. That's all recorded at TFS level. On the home page here, if I scroll down, I can see that there's a Fabricam Fiber team room. I can also see how many team members are in the room. I'm going to click it to enter into the room. On the left hand side, on the Room Explorer, I can see all the rooms I have access to. If I have permissions to, I can create new rooms as well as configure rooms. Here you can see some chats that have taken place in the past. Using the @ symbol, you can easily tag a team member to get their attention. If I scroll up a bit, we'll see there are work item change events colored in blue. Clicking on the link will open up the test case in the web access view so that I can see that test case or that work item. Purple events are change sets. Again, clicking on the link will open up the change set so that I can see the details. Let's configure this team room to get build notifications for a particular build that we've just set up. I'm going to expand Manage Events, select the build completion events, and allow the build by anyone to pass events through to this particular team room. We'll save and close that. I'm going to queue a new build. There we can see there's a new notification for the build. Again, if I click that link, it'll open up the build detail inside of the web access. I've opened up Visual Studio 2013 and here you can see the new improved Team Explorer. It's been redesigned and you can see some color has been added back into Visual Studio. We can also see that once I've set up a workspace for my source control, that I can see a list of solutions that I have under source control. I'm going to double click this Fabricam Fiber Call Center solution in the demo main folder. I'm going to debug this application. I'm going to click on the employees link to go to the employees page. I'm going to press delete on the last employee record, James Kernard. There's a confirmation page asking me if I'm sure I want to delete this employee. I am, so I'm going to press delete. However, when I come back to the employee list, I can still see that record. There seems to be a bug in the application. Let's close the application and go back to Visual Studio. The first thing I'm going to check is the data access layer. Let's open up the data access methods and go to the employee repository. I'm going to scroll down a little bit till I get to the delete method. I'll set a breakpoint on the delete method and we'll rerun the application. Again, we'll click employees, click delete, and click the delete button to confirm. The breakpoint is hit, so we're definitely getting into the delete method. However, there might be a complicated call stack. With Visual Studio 2013 code maps, I can visualize the complex relationships in my code. I'm going to right click on the highlighted line and select Show Call Stack on Code Map. Visual Studio draws the call stack for me on this designer surface. We can see that from the delete confirmed method, we got into the delete method of the repository. Let's stop debugging there. We can further augment this diagram. I'm going to double click the delete confirmed and that'll take me to its definition in the code. If I right click delete confirmed, I'm then going to select Show related items on code map, show methods this calls. That's added a few nodes into the diagram for me. I'm going to scroll up a bit to the edit method, and again I'm going to show related items on code map, show methods this calls. That'll add in all the code that the edit method is calling, and we'll do the same for the create method. We can see there's several calls to this externals. I'm going to expand the externals, and we'll see that the delete confirmed, edit, and create methods all call this redirect to action. So I'll right click redirect to action, select advanced, group, and remove from parent. Then we can delete the rest of the externals since they're mainly properties that we're not really interested in. Let's remove this reference to the employee repository delete method since we know that the concrete method is in the employee repository class, which you've already got on the diagram. Let's change the layout to be a left to right layout. And again, we'll delete this external code. Let's move these nodes around a little bit so we can see what's going on. We can see that before calling redirect to action, both the create and the edit methods call the save method. However, we can see that the delete confirmed method doesn't call the save. Let's add a note on delete confirmed here. I'm going to right click and select new comment, and I'll type in, shouldn't this call save? We can now share this diagram by using the share drop-down, and we could select email as an image. That'll allow me to email a team member with this particular diagram. We can also save this diagram for later use by going to File and Save Call Stack DGML. Let's go back to the controller method and add the call to save in the delete method. Let's build the solution and then right-click Delete Confirmed, and again show methods this calls to refresh the map. We can now see that Delete Confirmed has got a call through to save as well. Let's rerun the application to check that our bug fix worked. Click Employees, click Delete, confirm, and we can see that the delete method has been fixed. By using CodeMap, we were able to visually understand relationships in our code and quickly find problems. Code Lens, also known as Code Information Indicators, are a new feature to Visual Studio 2013. They give us a heads-up display with some information about methods within our code. You can see this as an extra line above each method within the code. Here I can see that this method has one reference. Clicking on the link opens up the reference. If I mouse over the reference, I get some context, so I see the line before and after the reference. Double-clicking will take me to the source of that reference. Let's go back to the index method we were looking at. I see the test case indicator saying that there's one unit test for this particular method. 0 out of 1 are passing, since we haven't run any of the tests yet. Again, clicking on the link will give me more detail. I can see that this method is tested in the getWeatherForWeek unit test. Let's hit Run All to go and run that test. We can now see that the indicator changes to 1 out of 1 passing. Again, if we double click, we'll get to the test case. Here in the code lens for the test case, we get an indicator indicating what the current result of the test case is. Let's open up another not run test. Here we'll see these tests have the indicator of not yet run, so we can see immediately which test cases have and haven't been run. Let's go back to Weather Controller. The next bit of information is the author of this file. We can see that Adam Barr authored this file. If we click that or click the changes indicator on the right, we'll see all the changes for this particular file in source control. If we mouse over that, we get a little bit more information on who checked in the change set and what the date of the change set was. If we right click, we can select View Diff. That'll launch the diff window to show us what code changed for that particular check-in. You can configure the code information indicators by going to the Quick Launch menu, typing Info, and clicking on the Text Editor All Languages Code Information Indicator setting. Here you can turn on or off code information indicators according to your preferences. One of the advantages of managed code is that you don't have to clear memory yourself. However, sometimes if you have leftover references to objects, the garbage collector is unable to clear those objects. The symptom of this is often what we refer to as memory leaks. These are hard to diagnose, but with Visual Studio 2013's new memory diagnostic tools, we can more easily diagnose memory issues. I have a pretty vanilla MVC application open here with just a few code changes to illustrate this principle. Let's run the application without debugging in IIS Express. Let's open up the performance monitor. I'm going to click on Performance Monitor, remove the processor time counter, and let's add a heap counter. I'll browse to .NET CLR memory, select the bytes and heaps counter, and then select the IIS Express instance. This is an indication of how many objects there are in memory. I can see that at the moment I have around 11 megs in memory. Let's refresh this home page 10 times. If I now open up the performance monitor, we can see that our memory is increased to 19 megabytes. This is a good indication that we've got a memory leak somewhere. Let's start the application again so we get a clean start. Here we can see our memory is at around 6 megabytes. I'm going to take a memory dump. There are many ways that you can do this. I use a tool called procdump from sysinternals. I'll tell procdump to make a dump of the IIS Express heap and dump it to dump1.dmp. Now again I'll go back to my web page and refresh 10 times. Again, looking at performance monitor, we can see that the memory is increased. Let's take a second dump. Now let's open up the second dump file. I'm going to say File, Open File, and browse to dump2.dmp. Visual Studio opens up the dump file and I can see some information like what modules there are. I can see that the IIS Express is in here. I'm going to come across to the Debug Manage Memory link and click it so that Visual Studio can analyze the heap. If I look at this, I can see most of my memory is held in byte arrays. If I expand those, looking down at the reference graph, I can see that the byte array is referenced from inside the models.user object, which in turn is referenced from the user array, which is inside the reference to a list of sample leak model users. That in turn goes to system object, which has pinned handle next to it. A pinned handle is some reference, like a static variable, that cannot be garbage collected. This seems to be the reason why my memory is not getting garbage collected. It also seems a bit strange to me that my user objects are so large. Let's now have a look at how we can compare this dump to a baseline. I'm going to select the drop down, hit Browse, and open up the dump1.dmp. That's going to analyze the difference between the two memory dumps. Here I can see that the byte array difference is 10, corresponding to the 10 page clicks that we had. So it's safe to say that each time we click on the page, we get a new array of bytes. At this point, a little application knowledge is required. I know that on the home page, we're accessing the user repository to check some data on the user. Let's again click on one of the instances, and we can see that we have a list of users somewhere. Let's do a quick search for list of user. That's brought me to my user repository. The first thing I can see is that there's a user cache here. However, the getUser method adds to the cache, but never actually reads from the cache before adding. This is probably the source of the expanding list of user objects. Let's also see what references the getUser method. Here's the index method of the home controller. We don't seem to be using much of the user object at this point in time. Let's go and have a look closer at the user object. The user object has a binary data property, which is a byte array. This is the source of the byte array objects on the heap. Since we don't need it at this stage, perhaps we can be a little bit more selective in what we're getting for the user object from the database. Let's go and fix those issues. Instead of select star, I'll select ID and username so that we don't get the binary data back. Secondly, I'll add the code that will check the cache before we simply add the user to the cache. I've added a bit of code to check the cache to see if the user is in the cache before we actually access the database. Let's again start the application without debugging to see if our changes have improved the memory usage. Our memory is sitting at around about 7 megs. Let's take a memory dump here to set a baseline. Let's again refresh 10 times. If we look at our performance monitor, we can see we've gone up a little bit, as we should expect, but we haven't gone up as much as we did before we made the fixes to our code. Let's take another memory dump, just so that we can verify the fix. Again, I'll close the application and open up the dumps in Visual Studio. Again, I'll click Debug Manage Memory to analyze the second heap. And here we can see that system byte is no longer at the top of the list for the most objects in memory. That's already a good indication. Let's now again browse to dump 3, the baseline for our second run, so that Visual Studio can do the comparison. Let's do a search for user. And here we can see that the difference in count is 0 between our first hit and our 11th hit. By analyzing the heaps, we've been able to fix a memory leak. TF Service, or Team Foundation Server in the cloud, introduced Git repositories. In TFS 2013, you get the ability to create Git repositories for your team projects with the on-premise version of Team Foundation Server. Here in the new team project creation wizard on the Specify Source Control Settings page, I have two choices. Either I can use Team Foundation Server Version Control, or TFVC, or Git as my backend version control system. I've already created a project called Agile Git that's configured to use Git as the backend source control repository. Let's connect to the Agile Git project. I'll click the Connect to Team Projects button in the Team Explorer, and that'll show me the team projects that I have access to. The Fabricam Fiber is a TFVC project, and it has a Visual Studio icon, while the Agile Git uses Git and has a Git icon. I'm going to double-click Agile Git to connect to it. A yellow information bar pops up at the top of Team Explorer to allow me to clone this repository. I'm going to click Clone. The clone repository function defaults the address for this Git repository. That's the URL that I'm seeing at the top. I'd be able to give this to any Git client and allow them to clone this repository. It's important to note that Team Foundation Server's implementation of Git is just that. It's Git. It'll work with any Git client. The second part is to specify what folder I'm going to map that into. I'm going to change the folder slightly. And click Clone. That'll clone the repository for me. In the Solutions section here, I can see that I'm on the master branch, and there's no solutions on that particular branch. I'll click New to create a new project. To keep things simple, I'm just going to create a Windows console application. We'll put it inside the folder we cloned for the repository. Let's click on Changes. Before we can do any commits, we're going to have to make sure we configure our username and email. I'm going to hit Configure to bring up the configuration. I'm going to enter in an email address for Adam and hit Update. Let's go back to Settings again by clicking on Home and Settings, and then Git Settings. Here you can see under Repository Settings, I have no default ignore and attributes files. I'm going to click the add link to go and add those files in. Those will help me with default attributes and default ignore specifications. Let's again go back to our changes. We can of course commit from within Visual Studio. So let's do that now. Initial import is my message and I'll hit commit. The commit and its hash come back in the Team Explorer window. If I click that, I'll get details of that commit. Let's make a change to this file. We've added some code in. I'm going to open up a PowerShell session. Let's change to the directory where we have our changes. We can see that there's an untracked change in this directory. Let's add it into the tracked changes by using git add. We can also commit this. I want to make sure that I do the commit against a work item. Let's go back into Visual Studio. I'll click on the home page for Team Explorer, open up work items and double click the My Tasks query. I can see that I've been assigned task 247. Let's associate this commit with that task from the command line. On the command line I'll type git commit -m to give it a message, adding console write line, and then I'll use #247 to associate this with task 247. We can see that one file has been changed. Let's go back into Visual Studio. Of course, if I go to changes, there are no changes since we've committed everything from the command line. Let's double click the task and go to all links. You'll see that the link hasn't yet been created. The link between commits and work items happens as an asynchronous job, so it'll take a few moments to process before the link appears. While we wait for that to update, let's push the changes from our local Git repository up onto the TFS server. From the point that we cloned the repository, we could have been working completely offline and disconnected from TFS. Of course, to push our changes to TFS, we need to be connected. I'm going to click Home, select Commits, and this will show the list of commits that are outgoing. I'm going to hit Push to push those commits up to the server. Team Explorer tells us that we successfully pushed 2 commits to Origin Master. Let's create a local branch. I'll select the master branch drop-down, select New Branch. Let's enter the name Dev, leave Checkout Branch selected, and click Create Branch. That'll create a new Dev branch for us. You can see which branch you're on by seeing which branch is written in bold text. Let's go to program.cs and make a change in the Dev branch. We'll go to Changes, and let's commit this. I'll type in Changed in Dev and hit Commit. That'll commit that change into Dev. We can easily switch branches simply by going to the Branches page and selecting the branch from the drop-down. If I switch to Master, I get the Master branch. Switching back to Dev will show me what's in the Dev branch. Let's switch back to Master and make a change in Master. Again, we'll commit that change by going to the Changes pane. I'm now going to select the branches and we'll merge. Here we can choose the source and target branches that we're going to merge. Let's merge from Dev to Master. I'll hit the Merge button. Most times the merges will work automatically, but every now and then you'll get a merge conflict. I'm going to select Resolve Conflicts so that I can see the conflicts. I'd be able to do this from the command line as well, or any other Git client that I use. I'm going to click on program.cs where the conflict is, and hit the Merge button. This will show me the source and the target branches, as well as the merged result in the bottom. I like both changes, so I'm going to select both of them. We can of course edit if we need to. Let's make an edit to the merge. And when we're happy, we'll select Accept Merge. We can now commit the merge by selecting Commit Merge in the Team Explorer pane. The comment's been auto-filled out for us, merge branch dev, which is fine. I'll hit Commit. We've now committed the merge in. While we've been working on our code, Brian's also made some changes which he's committed to the repository. I'm going to go to Commits. Before we push our changes, let's make sure there are no incoming commits. I'm going to click Fetch. Looks like we do have a commit incoming. It seems like Brian has made some changes to the code. If we double click the change, we can view his commit. We can right click and select Compare with Previous to see what changes he pushed up to the repository. Looks like he's also changed the console message. Let's do a pull to take those changes. Of course that results in a conflict, so we'll resolve the conflict. And again, we'll use the merge tool to merge. Once we're happy with the merge, we accept the merge, and then we can commit the merge. We'll select Commit. Let's go back to our commits and push our changes up. Brian would now be able to access the changes we've made on our local repository. Let's have a look at what we can see in the web access site. I'm going to click on Code. That'll open up the Code Explorer in Web Access. Here I can see my code. I can also see my history and see all the commits that have come into this repository. I'm going to click on the Adding CW247, and here we can see that this commit has been associated with the work item. If I click on the link, it'll open up the work item, and now under All Links I can see the link from the work item to the commit. We can also add comments using the lightweight comments function in Web Access. Finally, we can actually create multiple Git repositories in a team project. To do this, go back to the Explorer, and from the top menu here, we'll select Manage Repositories. From here we can create new repositories. We can also set access control and security on each repository. Visual Studio 2013 and Windows 8.1 now support coded UI testing for Windows Store XAML applications. Here I have a simple calculator application that's written in XAML, and I'm going to create a new project to do some coded UI testing. I'll right click the solution, select Add New Project, and under C# Windows Store I'll see the coded UI test project template. We'll call this bingcalc.codedui. Visual Studio then asks me whether I'm going to edit the UI map or manually edit the test. Notice there's no support currently for recording actions. I'm just going to select manually edit the test. Let's go and rename this class from coded UI test 1 to Bing Calc tests. And that'll rename the class as well. We'll also rename this coded UI test method 1 to test calc can add. Now we can add the code we need to launch the application, do some tests, and eventually close the application. To launch the application, we can use XAML window.launch. I'm going to right click, select Generate Code for Coded UI Test, and use the Coded UI Test Builder. That'll minimize Visual Studio and launch the Visual Studio Coded UI Test Builder. I'm going to use the Target button and start dragging over the tiles on my desktop until I find the Bing Calc tile. I'm going to let go, and the Coded UI Test framework is going to figure out the properties for that particular tile. I'm interested in this automation ID, so I'm going to right click and select Copy Value to Clipboard to get the automation ID for this application. Let's close the Coded UI Test Builder, which will bring us back into Visual Studio. Let's make a variable called app_id and hit paste to paste the value of the automation ID. We can now get a variable called calc, and we're going to use XAML window.launch, which is a static method, and this method takes in a string called app package family name, which is the automation ID we just captured. So we'll supply that app ID. Eventually we're going to close this window, so we can call calc.close in order to close that application. At this point we're ready to actually start interacting with the UI. We can do this using the keyboard or mouse namespaces that have been in Coded UI testing since Coded UI testing came out. Visual Studio 2013 now adds a new namespace called gesture, which has support for various gestures in Windows 8. Let's use gesture.tap. We'll first need to get the properties of a button so that we can actually tap it. I'm going to right click, select Generate Code for Coded UI Test, use Coded UI Test Builder. Let's launch the Bing Calculator. I'm going to grab my target and put it over the For button. The Coded UI Test framework inspects the properties of that control. I'm going to expand the flyout here. Let's rename this control. Let's just call this button 4. I'll then click the Add Control to UI Control Map button, and finally we'll click Generate Code. Even though we haven't generated a recording or a method, we can still generate the coded UI map. Let's close the recorder. You'll see now that Visual Studio has added the UIMap.UI test file. Double-clicking on that will open up the control map and the UI actions. If I expand the UI map, I'll be able to browse down the hierarchy to button 4. Let's now go back to our tests and add a gesture.tap. And then we'll walk down the control hierarchy to tap button 4. Let's look at the button 4 method. The button 4 method does a search on the buttons where the XAML button property names.name is equal to the text 4. We can use this to extrapolate our own search method without having to record additional buttons into the UI map. I'm going to expand the UIMap.UI test, double-click UIMap.cs, which is a partial class of UIMap where we can add customizations. Let's add a public void method called tapButton, which is going to take in a string called button text. We'll instantiate a button which which is going to be a new XAML button. I'll just resolve the namespace for the XAML button. When we instantiate the XAML button, we can give it a parent. Since we already have the parent, we can use that. The parent is the UI Bing Calc window. Now let's copy the search properties from the generated code. We'll then set the search properties and set the name equal to the button text. Finally, we'll call gesture.tap to tap the button that we've searched. Let's go back to our test. We can now call this method directly. Let's tap a few more buttons. We'll tap the plus button, then we'll tap the 5 button, then we'll tap the equals button. At this point, we want the calculator to display a 9, so let's add a step to validate the display. I'm going to right click, select Generate Code for Coded UI Test and use Coded UI Test Builder. Let's again launch the calculator application. I'm going to grab the target and drag it over the text box. I'm going to scroll down in the text box to the text property and click Add Assertion. Here we were able to choose various comparators. We'll just leave it as R equal and we'll default it to 9 since that's the result that we want from our first calculation. We can type a message for the assertion failure. I'll just type wrong result and hit OK. Let's go and generate that method. We'll call this validate result. And we'll click add and generate. Let's close the Coded UI Test Builder to go back into Visual Studio. The recording has added a validate result method that we've just recorded. Let's go and extend this validate result to make sure that it's a little bit more extensible. Again, I'll open up the uimap.cs class and we'll create a public void validate result that takes in an integer of the result we're expecting. We're going to call validate result, but before we call that, we're going to override the default. Every validation method gets an expected values property, which lets us override the values that are defaulted on the validation. This time it's UI item edit text, which we're going to override with the expected toString. Let's go and fix our test to use this new method. We now have all the code we need to launch the application, press some buttons and validate a result. I'm going to open up the Test Explorer window so that we can run this test. Let's change our grouping to group by class. Here we can see the Bing Calc tests. The other tests are unit tests in another project. I'm going to right click Test Calc and Add and select Run Selected Test. That'll launch the Coded UI test locally. The test is completed successfully. Let's copy and paste this method to create a subtract test. It would be as easy as changing the name of the method, test calc and subtract, and changing some of the buttons. So we'll tap 7 minus 3 and validate that the result comes to 4. Let's run that test now. Both our tests are succeeding. I'm going to check this in to source control so that I can run this as part of an automated build, deploy, test workflow. I'll enter the comment added coded UI tests and hit check in. Let's go ahead and queue the build to build our application. I'm going to go to the home page of the Team Explorer, click on builds, and queue the Bing Calc code build. That'll build our application. Now that we've checked in our code, we can associate that automation with tests. I'm going to open up the web access page where I've gone to the test hub. Here I have in my Windows 8 testing plan a suite called automated tests. Let's create 2 new test cases as placeholders for the automated tests. I'll call this test calc can add, and we'll save and close, and we'll add a new one called test calc can subtract, and we'll also save and close. Let's take note of those IDs, 249 and 250. Let's go back to Visual Studio and associate our coded UI tests with these test cases. Let's search for work item 249. I'll click Associated Automation and click the ellipsis button to select the test. Here I'll click Test Calc Can Add. We'll save that. This automates the test case. I'll repeat the process for test case 250 for the subtract case. We can see that our code build has completed successfully. Let's go and edit our lab build so that it can run those automated tests. I'll right click my Bing Calc lab build and edit the build definition. Under Process, you can see I've used the lab default template, which is configured by a wizard. I'm going to open up the wizard. I've selected my environment, Windows 8 Lab. I've selected the build. We're going to grab the latest code from the Bing Calc code build. Any deployment which needs to occur can be configured here. And finally, with test, I've specified that we're going to run the Windows 8 testing plan and the automated test suite. We can now queue up the lab build. The lab build completed successfully. If we want to see the results, we can click View Test Results to open up the results in the Microsoft Test Manager. That'll give us a detail of which tests have been run and what the results were. We'd also see any diagnostic data that was collected as part of the automation test run. TFS 2013 allows us to add comments to change sets from the web access. I've opened up web access and clicked Code to go to the Code Explorer. I'm going to click History to open up the change sets. Let's select this top change set by Brian. On the left hand side, if I click Comments, I can see that there's a comment over here. I'm going to click the comment so that it can open up. Here on the right hand side, I can see that Adam's made a comment. This is a file level comment. Adam can also make line level comments by simply highlighting the portion of line he wants to comment and selecting the comment on selected text. Control Enter will save that comment. The comment is also added to the list of comments for this particular change set. Thank you so much for attending today's webcast. I'll now hand over to Becky, who will tell you some more about our upcoming events and special offers.
Thank you, Colin. Would you like to know more? Imaginet offers a variety of free webcasts and events. To see a listing of or to register for any of our free webcast or roadshows coming up soon, you can visit our website at www.imaginet.com/events. Our next round of webcast topics include new topics such as top business benefits of application lifecycle management, what's new for ALM with Team Foundation Server in Visual Studio 2013, Enterprise Agile Management with TFS 2013, improved developer productivity, managing test labs without the headache, and coded UI testing with Visual Studio 2013. Imaginet is also offering 2 upcoming training classes in 2013. The first is an accredited core Kanban using Team Foundation Server 3-day class. This will take place November 13th through 15th in Dallas, Texas. The second class is a professional Scrum Developer 5-day class. This will take place December 2nd through the 6th in Stuttgart, Germany. Registration links will be included in our follow-up emails later today if you're interested in registering for either one of these upcoming classes. If you enjoyed today's webcast and are interested in adopting Team Foundation 2013, Imaginet can help. We have our TFS 15-day adoption quick start. This includes designing, installing, and configuring your Team Foundation Server and the Visual Studio development tools. Imaginet will teach you and your team the best practices for source control, build and release management, agile methodologies, and work management processes. It also includes support and training for your team and includes a high-level ALM assessment. If you're interested, just email us at info@imaginet.com. Similarly, if you already own Team Foundation Server and are interested in upgrading to the newest version, Imaginet offers our TFS 2013 15-day upgrade quick start. This includes planning and upgrading your existing Team Foundation Server to the newest version. We also covered the new best practices that exist in TFS 2013 around source control, build, agile methodologies, and the work item tracking processes. In addition, you will get support and training so your team is familiar with how to use the new features of TFS, and also includes a high-level ALM assessment. In addition to these 2 offers, Imaginet also offers a wide variety of ALM planning and implementation services. This includes other upgrade services, remote support, quick starts around lab management, manual testing, automated testing, and load testing, and also integration services that allow you to integrate Team Foundation Server with other products and tools. Finally, visit our Imaginet Visual Studio website for it's really your one-stop hub for all of your Visual Studio needs. Just visit visualstudio.imaginet.com. You'll be able to find all of our consulting services, training services, roadshows, and webcasts in one place. For any other questions or for more information, please feel free to contact us at info@imaginet.com or by calling 972-607-4830. Thanks again, and we hope to see you on another Imaginet webcast.